Okay, so I'm going to be going over word problems and problem solving. This comes from section 2.4, and I'm going to be basically going from a high levels to kind of, the things that you want to look for when you have word problems, so that you can start looking for these things, because they will make solving word problems easier. And then knowing the different types or categories of word problems helps, because if you can categorize a problem, then you can look for similar problems to see how to solve them. So when we have word problems, we call this mathematical modeling. So if you are told to write a mathematical model, that is telling you to write an equation that fits the situation, the real life situation. So sometimes people don't make that connection. What does that mean, mathematically modeling? And it's like, okay, write an equation representing whatever the situation is. And doing this is hard for a lot of people because you're taking the algebra that you've learned and now you're trying to create something new from it, because everything you've seen before is you're given the equation you just solved. Here you're trying to create the equation, and so you have to use critical thinking, which involves a lot of how do these things work in the real world and trying to see the relationships between things. It's so it's like, okay, I know in the real world that, let's say, income goes up the more I work or something like that. Knowing whether things should increase or decrease, understanding how things are related. Are they, do you multiply your salary per hour by the number of hours you work? Knowing those kind of things. Problem solving is related to critical thinking, where you're trying to figure out, okay, how does all this fit together? You need to know how to translate words and phrases into what they mean in math, because if you can pick those words out and translate and say, oh, this means that I'm going to be multiplying, this means I'm going to be adding, that helps when you're trying to create your equation. And then just understanding mathematical concepts overall, so that you understand the types of equations you're creating and what the outcome should be or should look like. If you understand, oh, this, like if you're solving and your answer doesn't make sense, then that says that your equation might have been off. So trying to fit together what you learned so far about math, trying to translate, learn the definitions, take the English into math, and then trying to piece it together with what happens in the real world. So it's really difficult for a lot of people. This link that I have here is the same link that I mentioned in my course intro. It is in the supplemental material. Most mathematical modeling in the world that is very complicated. What we're going to be doing today is like one equation mathematical modeling, or maybe two equations we're going to fit together. In the real world, when you actually are creating mathematical models, they usually are multiple equations, multiple variables. They're very complicated, and we use computers to solve them. And the hardest part is getting an answer and then, oh, well, did I set up my model correctly? Because if the model's wrong, then whatever your answers are or you get may not be correct. So mathematical modeling is used a lot in the world, just at a higher level than what we're doing here. So some tips for successful modeling to help you with the word problems is to keep a list handy of common words and phrases, what they are in English, what that translates to in math. In the supplemental materials, I actually have a file that you can print off, download and print off, that has keywords to look for. So definitely I would put that into your notes. Keep a list of common formulas and equations that you come across. So if there are geometry problems where you're doing a lot of things with area of different shapes, you might want to list what those formulas are for each different shape. Another equation that comes up in modeling is distance equals rate times time. So there's certain formulas that pop up over and over again. So having those written down as you encounter them, then you can just have a cheat sheet of formulas that you might need. I strongly encourage you to draw pictures whenever possible, because a lot of people are visual, and if you can draw a picture of the situation, and this is very helpful when you have geometry type problems that it translates it out of just like a big block of text into something that you can actually see and understand. Not not every problem you can draw pictures with, but it is very useful if you can draw a picture to draw a picture. And if there's like a problem, I'm sure you've heard of those problems where like you've got two airplanes that are flying past each other and you're trying to figure out what time they meet or something like that. Even though all you're drawing is like a picture of airplanes heading towards each other, even just that picture to me usually helps me. And then always start with writing down what you know and what you need to find. I see a lot of people, they go through a whole bunch of work, but their final answer isn't actually what the question was asking for. So you want to make sure from the very beginning that you identify, well, what is it I'm actually looking for? So that way you can make sure that when you get your answer, that is what you want. So this is the general problem-solving procedure, and I'm going to zoom in so that we can kind of go through it step by step. This is also in the textbook. So the first step is just to read the problem. And so when I do the reading process, sometimes I read it multiple times. So don't expect that you're going to read it like, once and then know how to do it. You actually need to read the word problem multiple times. The first time is usually to read it to get an idea of what's going on. Then you read it a second time to pick out the information that you need now that you know what you're looking for. Read it a second time to start jotting down information, drawing pictures. So I definitely recommend reading the problem multiple times. Once you've read the problem and you've written down what you know, what you're looking for, kind of drawn some pictures, then you want to start picking your variables. And whenever you pick a variable, write down what it represents. Because if you just say, oh, if you use X, X in a real world problem like isn't very explanatory. Like if you're doing a problem where you're trying to find the distance between two things, X doesn't immediately say to me distance. So you'd want to say X is distance between blank and blank. I try to do variables that make sense. Like I'll use D for distance, T for time. I try to use variables where the letter matches what I'm looking for, because then it kind of makes me remember what it means. So pick variables, write down what they represent, and then this is where you start writing the relationships between things. So sometimes they'll tell you that one thing is twice another thing. So you may be writing that down and just kind of jotting down the little pieces of math. But you haven't written any equations yet. You're just kind of taking what you're seeing and starting to put it into math forms. Once as you're picking it apart, and once you've picked everything apart and you've got all the different pieces of information, then you need to put it together into your equation. So generally, for what we're doing, there's not going to be more than two equations. Most of the time, it's one equation. Sometimes you can write it in two and create one equation from it. The way the book does it is they always put it in one equation, but sometimes I find it easier to have a second equation that's like an intermediate step because it makes more sense to me. Sometimes if you're struggling to write an equation, it helps to actually write the relationship in words to write down how things are related and then write an equation, because sometimes they don't give you the full picture in the word problem, and so you have to rephrase it or maybe say it out loud, kind of talk through, okay, what does this mean? How is this related? And then that helps you translate it. Those are those first three steps are the hardest steps, because once you have the equation and all you're doing is solving, and that's something that you know how to do. So it's really the first three steps that are hard. So then once you have your equation, you solve, and then you need to double check that what you have makes sense. So you want to make sure that it checks in your original equation. You should always check your math. You want to make sure that the answer seems reasonable and that you're actually answering the question that was asked. So I teach pre-calc, and I just finished grading their assignments where they have a lot of word problems. And there were a lot of people that never actually answered the question that was asked because they solved, they got an answer, but that was the step needed to answer the original question, and they didn't go far enough. They didn't actually go back and answer the question. I also saw some people that got answers that were completely wrong and they didn't notice it. So for one example, there was a problem where they were trying to determine how much money to invest in a certain bank account to make a certain amount of interest. And they had $32,000 to invest, and their final answer said they should invest like $33 million. Well, you can't invest that much if you only have $32,000 to begin with. So getting an answer that's way off like that, that's impossible because you don't have that much to begin with, should indicate that you have an error somewhere. So if you get an answer that doesn't make sense, that is most likely a problem in the original equation that you created. So if it's not a problem in your solving, then your equation is not set up right, and that's where you should get some help. Maybe look at some additional examples, use tutor.com, or send me a message and say, here's what I have set up, where am I going wrong? Because that's usually where the error is. So once you've checked everything, your answer makes sense, it answers the original question, you double check the math, then you want to state your answer, and this is very important. When you give your answer, you don't just give x equals 2 and just box it, because you made up your own variables. So for somebody else looking at your work, if they don't know what your letters mean, just saying x equals 2 and they don't know what x is, that's not going to be meaningful. So you should always give your answer in a sentence because these are word problems. So you answer it in a sentence and you provide the context. And apparently that was supposed to say the word possibly. Whenever possible, not problem. My brain just wrote problem twice. So let me fix that. Never possible. Okay, and then zoom in again to that. Unfortunately, it doesn't fit. It only has one zoom. So let's say you were solving a problem and it was asking you at what time 2 trains will meet. So you would not just 2 o'clock. You would say these 2 trains will meet at 2 o'clock. So you have to reference what the original problem was and what the question was. You're basically restating the question, but with the answer. It's kind of like the opposite of Jeopardy, where you have to answer it in a question. It's like you're given the question, now take that question, make it a sentence with the actual answer. And that's how you have a word problem. You should always answer that way, because that way people can actually follow your work and then they understand what the final answer is, and it has meaning. It's not just some random letters. You want to put it back into English. So that's the problem solving procedure. I recommend, like all of these slides, oops, try and, just print them out. I'm going to share these. I'm probably going to make it a PDF so that way you can print them out so you have them handy to reference. Okay, so in order to successfully do word problems, you need to be able to translate English words into math. And in the first chapter, chapter 1, there is they go over some of these words and what they look for, or like how you translate them. But it's important to, have it see it more than once so you can really, it will stick in your brain. So there are some things that are indicators to help you do the translation that are not actually in the textbook. And actually, I've never seen this used anywhere other than me. So these are the key things to note. So if you have a complete sentence, it will translate into an equation. If you have a phrase, it's an incomplete thought. It's like you're reading off English and it doesn't finish. That means you have an expression. It's not complete. So the difference between them is that if it's a sentence and it's an equation, it has an equal sign. Otherwise, there's no equal sign, and it is an expression. If you have multiple phrases, like there may be commas involved, or it's pretty long and there's like maybe even some parentheticals or something like that, that is usually telling you when you translate there are going to be parentheses involved. So there are key indicators about English that you can look for that help you translate it into the math. Verbs. So verbs in English are those action words. And when you see a sentence that you need to translate and it has a verb, that is usually telling you that's where your symbol is going to be, whether you have an equal sign or a not equal sign or something like that. Verbs will have is, was, are, those type of words. And the word is generally always translated into an equal sign unless there's other things with it. So if you see is less than, is greater than, is less than or equal to, is greater than or equal to, is not equal to, those are other symbols. But if it's is by itself, that's always going to be an equal sign. So one of the first things I do when I'm trying to translate, and if I have something that can translate directly, is I just look for where the equal sign is. Words like and, or if you see words like of, by, from, per, than, that's where the symbols get put. So those are telling you where a plus sign might go, or where a minus sign might go, or a division or multiplication. Those are indicators of where you're going to put that symbol in relation to your translating. And then one thing that I do is that I always translate subtraction as adding a negative instead of subtraction. It means the same thing. Subtracting is adding a negative, but doing it that way eliminates a lot of errors because subtraction sometimes gets translated in the reverse order that you read it. So if in English, we read it from left to right, but subtraction somehow gets translated on some instances from right to left. But if you do it as adding a negative, then you can always go left to right and you don't have to worry about that. So these are just some guidelines and I will demonstrate these. Again, very handy to have this like printed off somewhere. So these are keywords that you're looking for. And I've indicated where the order matters, where it doesn't. This is basically a screenshot of that printout that I talked about that's in the supplemental materials. So words that mean addition to, more than, some, increased, total. Words that mean subtraction, and there are two that you would have to put in an opposite order unless you follow the adding a negative thing. We have words that mean multiplication. We have words that mean division, and exponents here, a few exponents. So having this printed off handy so you can even see examples of how it translates, what it would look like when you're using letters and numbers, that is just, it's good to have this while you're going through all these word problems so that you have, you have a lot of handy things to look off of. So let's do some translating. We're going to start simple. The most simple word problems don't really have real world context. They're just literally translating English words into math. And once you get good at that, and then you can start adding in the more complicated context where you have to start learning the different types of word problems. But let's just start with directly translating English into math. So I'm going to start with my first example, the one on top. It says 15 less than a number is 41. So first thing I always do is look for the word is. So I've got an is, so that's going to be where the equal sign is. So I look for where that is, where the verb is, there's my equal sign. Because the less than is not next to is, that means it's going to be subtraction. So if less than is next to the is less than, that is the less than symbol. But if it says less than, and then it has a gap between the is, then those are two separate things. And one is subtraction and then one is the equal sign. So that's something to keep in mind. So if you just see less than, that doesn't necessarily mean it's always a less than symbol. You got to look for where the is located. So because we have less than and it is separate from the equal sign, that means we're going to be subtracting. And I said that we're always going to do subtraction with adding a negative. And when we do that, we're going to make, let me read through this again. So again, sometimes I have to read through this multiple times. So 15 less than a number. So 15 less than a number means that you're subtracting 15. So that means I want to make my minus sign, my negative, to be with the 15. So this is going to be written as a negative 15 here. So that's when you see a less than in this context, the number in front becomes a negative, subtraction adding a negative there. So I've just translated that. And then I said, and let me go back to the slide, that the word than is a location of the symbols. So we have the word than in the less than. So I'm going to go back to our example. And if we're doing subtractions, adding a negative, so that than is going to become a plus sign. So anywhere I see a than and, I'm going to just put a plus. Now I've got my subtraction, which I'm indicating is adding a negative. So I've translated the 15, I've translated the less than, I've translated the is, all I'm left with is the number and 41. So if it says a number, then that means it's a variable and you get to choose what variable you want. It's not giving you a letter to use, so you can choose anything you want. I usually use n for numbers, so I'm going to write n right there. And then to the right of the equal sign, I have the number 41, so I just fill in 41. So once I've translated everything in this sentence, that is my final answer. So it's negative 15 plus n equals 41. Or if you want to write with subtraction, you would say n minus 15 equals 41. That is the alternate way to do that. But I like to make sure that everything is left to right in the same order, so that's why I put the negative 15 instead of subtracting a 15 there. Are there any questions? Okay, so let's move on to the second equation, or the second example here. We have twice the sum of a number and negative 2 is 16. So I'm going to look for where the word is located, and then that's going to give me an equal sign. So I always do that first. Then I start kind of going from left to right. So I've got twice. Twice means you're multiplying by 2. So twice means 2 times, and then I'm multiplying everything that follows by 2. If there was a comma in there, then that's where the parenthesis would stop. But there's no comma, so I just keep going until I hit the equal sign. So everything that follows is going to be in parentheses here. Now we've got the word sum. So the word sum means addition, and the symbol goes where the and is located. So that's going to give me a plus right here. Next, I'm going to fill in the blanks. So the sum of a number, so we'll use n to represent that number. And then the next blank says it's -2, so I'm going to put -2 there. Then I have my is on the equal sign, and then on the right, I have 16, so I'm going to write 16. So once you filled in like your symbols and the words, then you're looking for where the gaps are, and you're literally reading it from left to right to fill in those gaps. So our final answer is 2 times n plus -2 equals 16. Are there any questions? Okay, we're getting more complicated here. The one on top, we have 3 times a number is the same as the difference of twice the number and 7. So I'm looking for my is. So we've got is, and when it says is the same, that's still part of the equal sign. It's the same thing, equal signs, the left and the right side of an equal sign need to be equal so they are the same. So is the same, that whole thing translates as an equal sign. So now I'm going to work left to right. So 3 times, so 3 times means multiplication. So I'm going to use a dot. So that 3 times is going to be 3 and then a dot. And then basically I like to put parentheses until I hit the equal sign just to be safe. So I'm going to just skip that for now. And then if on the right of the equal sign I have as the difference, so difference here is subtraction. And the way that the difference works is that you don't have to do a negative in this case. And the subtraction symbol is going to go where the and is. So I'm going to move, and I'm going to have my subtraction symbol with the and. So that those ands tell you where those symbols are going. So now I'm going to kind of start filling my blanks here. So I'm going to switch. I'm going to go to the left again. I've got 3 times, and then I've got a number. So I'm going to just use n to fill in that blank. Equals. So I've translated as the difference of my next part is twice the number. So twice the number means 2 times the number. So I've got 2 times, and then our number is n. And then 7 is in the next blank. So reading it left to right, we have 3 times n, or 3 times a number, equals, or is the same as, the difference of twice the number and 7, which is the same as twice the number minus 7, or 2n minus 7. So I can simplify this by writing 3n equals 2n minus 7. Any questions? Okay. Bottom one. We have the difference of 14 and 3 times a number is the same as the sum of the number and negative 10. So I'm looking for my is. And we've got an is the same, so that's going to be where my equal sign is. So now I'm going to work left to right. So we've got the difference of, so that was one where you look for the and that's where your subtraction symbol is going. So I'm going to put my minus sign there. And then I'm going to just move to the right of the equal sign. And it says as the sum, which is addition. And so the plus sign is going to go where the and is. So I'm going to have a plus sign right here. So I've sort of put in all of my symbols just for those particular parts. Now I'm going to kind of move left to right again. I read through these multiple times. I read through the sentence multiple times, filling in the blanks to make sure that everything's where it should go. So if I go back again, I have the difference of, which I've translated. Next is 14. So I'm going to put 14 right there. Then I have my and, which is a subtraction. Next, it says 3 times a number. So that is literally 3, the times symbol, and then we can use n for the number. We saw that in the above example. Got is the same, so that's my equal sign. And we've got the sum, which told us we're going to be adding what comes next. And we have the number, which is n. And then after the and, where the plus sign is, we have negative 10. So we can write this. We have 14 minus 3n equals n plus negative 10. Are there any questions? If you need, like, if you're really struggling with translating these things, you can pick out the odds in the book from section 2.0. There's a whole bunch on translating just from English into math, and so you can use that to help practice translating and getting the equations. It kind of helps you learn the vocabulary as well, because you have to learn what does each word mean and how do we make that math. And actually, before we just had our discussion about all these symbols, before a lot of these math symbols were invented, people had to do math in words. So this is sort of a holdover, and you'd have to write like a whole sentence to indicate just what the equation was. So now that we've done some of that, let's actually start getting into the word problems where you're involving real life situations and the different kinds of things that you may see as you start seeing word problems. So these are not in any particular order, but we have what are called consecutive integer problems. And there is actually a video in the classroom on talking about consecutive integer problems. Consecutive integer problems are where you're adding consecutive integers together. And consecutive just means they're one after another. So like 1, 2, and 3 are consecutive integers. You could have consecutive odds like 1 and 3, or consecutive evens like 2 and 4. Consecutive integer problems are usually used in combinatorics and cryptography and those kind of fields where you may have a key and then you've got multiple numbers that you're kind of running to try to encrypt something or decrypt. And so those are where consecutive integer problems kind of pop up, is in those sort of fields. So if you're doing like a computer, like an information security, you may see some of these types of problems. or maybe some of the things you'll learn were based off of these types of problems. The next I just call geometry problems, and these are, let's see, it's 2.6, and there is a video in the classroom on these are in different locations. So the consecutive integer problem is in the weekly content, and the geometry problems are on the videos on the left sidebar. So those are in two different locations. So geometry problems are, I mean, they're things that have to do with area, circumference, radius, perimeter, angles, shapes, essentially. And one that I consider geometry problem is if you're cutting something into multiple parts, because usually that is like if you have a piece of lumber and you're cutting it into multiple parts, you use geometry because it's usually you're woodworking or doing something like that, and they're very much related, and you have like a shape that you're cutting. So I throw those under geometry problems. Cutting something into parts is actually covered in 2.4, but I consider it part of the same thing because you've got like a physical object that you're getting information about. If you have any problems with area, it's just look up the formula for the shape so that you know what the formula is. Perimeter is you add up all the sides. If you have things about angles, complementary angles add up to 90 and supplementary add to 180. The inside of a triangle has 180 degrees. So those kind of things may pop up a lot, and those are easily things you can look up. You can just Google what is the formula for this, what is the formula for that, so that you can work out these types of problems. Next, I have distance, rate, and time problems. So this is actually 2.7, which you don't have to read 2.7, but there is a particular formula, or distance equals rate times time, and rate is basically speed. So if you take your speed and you multiply it by how long you're at that speed, that will tell you how far you went. And that makes sense. If you're driving 60 miles per hour and you've gone 2 hours, then you've gone 120 miles. Because if you 1 hour at 60 miles per hour is literally 60 miles. So if you think about the relationship of things in the real world, you can come up with an equation like this without having to have it written down. Distance equals rate times time just literally sort of comes from the units. If you take miles per hour and multiply by hours, the hours cancel, you're left with miles. So you can even figure these out by units without even an equation. So that's another skill when you're trying to figure out word problems. If you have things with different units, use the units to kind of figure out what you need, to see what you need to multiply together so that things cancel. It's like dimensional analysis sort of thing. That's a good way to solve problems if you have things with different units. So the distance, rate, and time problems are usually those airplane problems, those train problems, those ones that are in standardized tests that everybody hates. Or a lot of time you'll see one with like a current. A boat is going one way with the current and then without the current, or something where airplanes with the wind or against the wind. But if it involves your distance, your speed, and some time, it's in that bucket. The next categories I call total problems. These don't have an official name, but this is what I group them together. Usually you're adding things together and these things are related in some certain way. Or you maybe have things that cost different amounts and you're adding them together. So an example would be if I'm adding my pen collection, and I have a certain number of pens, and I know that my friend has twice as many pens. How many pens do we have total? That's a total problem. Another common total problem would be if you've sold this many adult tickets, this many children tickets, how much money did you make total? And you know like how much each one costs, something like that. So you're basically trying to add things together and you're given a total. The next category is percentages, and these are specifically covered in 2.5. So there is a video on the left videos area. Maybe that should say in. So the videos link on the left side, that's where I have a video for 2.5 where you're going over the different types of problems you have involving percents. So usually these are problems where you're trying to determine how much tax something has, or you want to know the amount before tax. You might be doing discounts. You might have a markup if you're selling something. Another one that I didn't list is tip. That's usually percentages. If you're looking for the percent change or percent difference, how much, if it increased from this number to this number, what percent increase did it have? Interest problems show up here too, because when you're finding interest on a bank, you're using percentages. You have an APR, an annual percentage rate, and you're trying to break that down. So those are all in the same kind of bucket, and a lot of those are set up the same way. Those are usually set up with proportions, and once you understand the setup, it's pretty simple to translate. And then the final type of word problem that you usually see are called mixtures. So these are also in 2.7, which we are not covering. So mixtures, you can mix things with different percentages. This is, you say gasoline, you have different octanes of gasoline, which are actually percentages. So if you have like an 87 octane and a 92 octane and you need to make an 89, you have to mix these two different types of things together. In chemistry, you're usually doing a lot of mixtures. So you may have you're trying to mix pure water, which is 0% of something. Because let's say you're mixing it with like hydrochloric acid, and your hydrochloric acid is 20% hydrochloric acid. You're trying to add water to it to dilute it down to say 10%. How much do you have to add? So those are the types of mixture problems you can see. So if you're in chemistry, you'll see mixture problems a lot. And then mixing items with different costs. So one common example is if you're making a bag of mixed nuts and say walnuts cost this some amount, almonds cost something else. If I'm mixing some number of pounds of walnuts plus some number of pounds of almonds, how much should I charge for the final mixture to what would be an appropriate price based off of the amount that you put in. So that's another use, and that's actually good in businesses. If you are making your own mixed bag of some sort of item, you can use a mixture problem to figure out how much you should charge. So these are lots of different types of word problems, but the way to solve each of these type of word problems is very similar. So when you're going through the homework and doing practice problems and going through the reading, try to write down your notes, write down which category each of these fits in. So that way, when you go back, you can identify, oh, this is a percent problem, so this is how I set up these. Or this is a distance problem, this is how I set them up. That will aid you a lot. Because the more you see them, then you'll see the relationships and see how they tend to be set up the same way, depending on what category it's put into. So that will help you out a lot with word problems, is identifying the category so that you know what the general setup looks like. So I don't have a lot of time because these are a lot of tips that they don't give you in the book. So these are tips that I have gathered from solving word problems many, many times. So I don't have a lot of time to actually do word problems, but there are videos in all of these, plus plenty of examples in the textbook. So here's my first one that we've got. A rope is 54 inches in length and must be cut into 2 pieces. If one piece must be twice as long as the other, find the length of each piece. So as soon as you see that something is being cut into 2 pieces, this falls into my geometry problems. And whenever I have a geometry problem, I draw a picture. So this is supposed to be a rope. I can kind of try to, depending on how much I don't know what the braiding on a rope really looks like, but that's my rope. So I'm just drawing a picture. So I always draw a picture when I have geometry problems. And then I read the sentence again, read the problems again, and start to kind of pick apart the information. And I use color coding to kind of help me. So it says that the rope is 54 inches in length. So that means the distance is 54 inches. And it's always important to pay attention to the units because you should always give your answer in units if you have units. So that whole thing is 54 inches. And then it says it must be cut into 2 pieces. So I know I'm going to slice it somewhere. And then one piece must be twice as long as the other. So I'm going to just kind of eyeball that. It's not going to be perfect, but I'm going to just roughly cut it up. So I've got my picture. And then what we're looking for is to find the length of each piece. So we might have a shorter piece and a longer piece to kind of identify these, because one is longer than the other. I usually don't like using the letters S and L because S can look like a 5 and L can look like a 1. So I'm going to just use X and Y. And let's say X is going to be the short piece, and then Y is going to be the long piece, just so that I remember which one those are. So I've read through the problem, I drew a picture, I'm starting to pick out the information, but I haven't created my equation yet. I'm still going through the reading process and trying to kind of figure out what I have. So I picked my X and Y, so I'm going to just label those on the short piece and the long piece. And I'm going to go back and read the sentence again, or read the problem again. A rope is 54 inches in length and must be cut into 2 pieces. So this is one where you may need to reword it. So what this is telling us is that when we have these 2 pieces, they add up to 54 inches. So this gives me an equation, x plus y equals 54. So the total length between those 2 pieces needs to be 54 inches. So now I'm going to move to the second sentence. If one piece must be twice as long as the other. So I'm going to rewrite that so we can do a translation here. If one piece must be twice as long as the other. If I remove the word is, I have a sentence. One piece must be twice as long as the other. So I'm going to start translating that. So I'm going to look for my verb, and in this case it's not an is, it's a be. So be is where the equal sign is going to be. So now I'm going to take a look at what I've got here. I've got one piece must be twice as long as the other. So the one piece that's twice as long must be the longer piece. So this one piece needs to be the longer piece, because that, it says, must be twice as long as the other. So I'm going to make this equal to y. Then I have twice as, so twice is multiply, and then long as the other piece. So the other piece must be the shorter piece. So now I've just translated that second sentence. So I have 2 equations here, which is completely fine. So once you've kind of translated every sentence, we translated the first sentence in the problem, we did the second sentence, now we need to actually do the solving. So this is a little trick here. From what I've translated, y is equal to 2x. So I have a y in my first equation, I have a y here. What that means is if y is equal to 2x, then I can replace y with 2x in my first equation. So I can rewrite that first equation as x plus, and then instead of y, I can write 2x because that's what y is equal to. And then that equals 54. So I took that second equation and it allowed me to replace things in the first equation. And now I can solve because I have a 1 variable. So I can add my like terms on the left. 1 plus 2 is 3. So I have 3x equals 54. Now I need to divide both sides by 3. And I'm sort of running out of room here. So 54 divided by 3 is 18. So this gives me 18. So I know since x is 18, x is a shorter piece, that is 18 inches because we have our units. Now I need to know what the longer piece is. So I'm going to go back to my equation, y equals 2 times x. So that's going to be 2 times 18, and that is equal to 36. So the longer piece then must be 36 inches. And I should add those together to make sure they add up to 54. That's just a check to make sure your answers make sense. So 18 plus 36 does equal to 54 inches. So that works out. So we've done all of this math. Now we want to actually write our answer where we write it as a sentence. So we would say the shorter piece is 18 inches long, and the longer piece is 36 inches long. And that would be your answer. Are there any questions? Okay. Another example here. So Maria has 15 fewer apps on her phone than Orlando. If the total number of apps on both phones is 29, how many apps are on each phone? So I see that it has the word total, so this means that this is going to be a total type of problem. So that means I'm going to be adding things together. We're looking at the number of apps, how many apps are in each phone. So we have the number of apps that Maria has and the number of apps that Orlando has. So for Maria, I can use M. I'm going to just kind of pick a variable. So that is going to be the number of apps Maria has. Now for Orlando, picking O would be confusing because it would look like a 0. So maybe I'll just pick X, just some random variable. So the number of apps Orlando has. I don't really have any pictures to draw in this case. Total problems, you generally don't have pictures like you would in a geometry problem. So I identified, okay, it's going to be a total, and I've got some variables. So I'm going to read through this a second time. And I'm going to try to translate these. So I'm going to rewrite my sentences here. Maria has 15 fewer apps on her phone than Orlando. So we're going to translate that sentence. So has is one of our verbs where we have the equal. Like is, it's going to be a verb. So that's where our equal sign is going to be. So to the left of the equal sign, I have Maria. So I must have Maria, my variable for Maria there, because I have nothing else on there. Now, we have 15 fewer apps. So if it's the word fewer, this is telling you you're going to have a negative 15. It's going to say subtraction. So I'm going to write a negative 15 here. So that fewer means we've got less than something. So there's 15 less. So I'm going to have a negative 15. And then when I use a negative, we're adding a negative. So I'm going to find where the word than is that translates to a plus. Now we've got, let's see, so we've got 15 fewer apps on the phone. Doesn't really mean anything. It's not useful here. All we need to know is how many we have. That's just kind of like a unit almost, so we could ignore that. And then after the plus sign, we have Orlando, which I said was an X. So we've got our equation, M equals negative 15 plus X. So I've translated that sentence. Now I'm going to go back to the problem. So that was the first sentence. Now we have the total number of apps on both phones is 29. So I'm going to just rewrite that so you can see the translation. So I'm looking for my is. So I'm going to have my equal sign. And immediately to the right of the is, I've got 29 and I have nothing else over there. So I can put my 29. We've got the word total, which is going to be a plus sign. So it says the total number of apps on both phones. It doesn't really directly translate, but it's just going to tell us that we are adding our variables together, m plus x, because those are the number of apps on both phones. So it doesn't directly translate, but knowing what total means allows you to write that part. So now we're going to do the same trick that I did in the previous problem, because we have two equations here. So I know that m is equal to negative 15 plus x. So I can replace m in my other equation with negative 15 plus x. So I'm going to rewrite this here. Instead of m, I have negative 15 plus x. And then I've got my plus x already. And then I have my equals 29. So now I'm going to start solving. So I have an x plus x is 2x. So I have negative 15 plus 2x equals 29. So to solve, I need to get the x by itself. So I'm going to add 15 to both sides. I know I'm kind of running out of room here. So I'm left with 2x equals 34. Now I'm going to just use a little arrow to follow because I don't have enough room. So I need to divide both sides by 2. So I'm going to just rewrite it so you can see we did 34 divided by 2, and that gives us 17. So we found X, so Orlando has 17 apps. Now the question says how many apps are on each phone, so we also need to figure out how many Maria has. So Maria has 15. Did I do my math wrong here? This doesn't add up to 29. Like, wait a minute, let me double check here, because 15 fewer apps on our phone than Orlando. 15 less than Orlando, okay. Negative 15 plus x, 2x plus, oh, I did that. I'm going through. This is what we do in a word problem, because I realized 17 subtracting 15 is 2. 2 plus 17 doesn't equal 29. I made an error. Where was my error? I double checked. It's not in the equation. It's on the fact that when I added 15 to both sides, I actually wrote 5 on one side. So it's really 29 plus 15. I need to make sure that I'm being consistent. So that gives me 44 instead of 34. So that's 44 divided by 2, which comes to 22. So Orlando has 22 apps. Maria has 15 fewer, so all I need to do is subtract 15, which gives me 7 apps. And now when I double check, 7 plus 22 equals 29. So now I know that I've done something right. So this is one of the things when you're problem solving is you want to think, are my numbers making sense? You don't want to just blindly solve. You want to double check. I double checked and I realized, wait, I made an error somewhere. So now that we know Maria has 7, Orlando has 22, we need to write this in a sentence, which I don't have a lot of room for, but I will try. So Maria has 7 apps on her phone, and Orlando has 22. So I'm putting that in context, saying what my variables were, what we were looking for, so that way I can, it actually sort of makes sense there. Are there any questions? Okay, so no questions there. Hopefully this is all making sense to you guys. We have now hit 8 o'clock. I know that I did a lot of stuff. I did go into, these are the two, big types of problems you see in 2.4. The important thing is mostly all of these notes, the common types of problems, the word problems so you can identify them, the translating, the keywords. So I'm going to definitely share this PowerPoint so that you can print all these out and have these in your notes, because that's going to be really helpful. But hopefully you can see you can see how I've been going through this, what the problem solving process is, how I'm figuring it out, what I'm doing with my variables, because that's going to be the same process that you are going to be doing. You have to sort of determine what kind of situation it is. And this one with the rope could be considered a total type of problem because we're still adding things together to get a total amount of 54. So this could be in the same kind of bucket as the total problem. And the steps were similar, but the translation was different. But we still had a total where we added things together, and we had to still take some equation and put it into the other one so that we can finish solving. So they're very similar. The word problems may see completely different, situations totally different, but when you start translating it, you see, wait a minute, we're working with a total here. We're doing the same sort of steps. That's the important part. If you can recognize that, and you can recognize the different types of word problems and that you're doing the same thing over and over and over again, then it will start to make sense and you'll start to recognize it, and then it will get a lot easier. So are there any final questions for me? I would stop sharing, but I couldn't get my my webcam to work, so it would just be a blank screen if I stopped sharing. So are there any final questions on this? Okay. Well, I'm going to make sure that I email this out tomorrow along with that PDF. Like I said, you'll get the video in your email. Definitely check out the other videos that I mentioned, the consecutive integers that is in the weekly content, and then sections 2.5 and 2.6, which are in the videos section on the left side of the classroom. Those will help you a lot with the word problems. If you do the same sort of process that I did here, identify what type of problem, that will help you out on the homework, and then of course it will help you out on the quiz as well as you start seeing these word problems. So I thank you guys for sticking with me for an hour. I really appreciate it. I'm glad that you guys were able to attend. And I'm going to sign off here. So I hope you guys have a great night, and I will talk to you guys later.